Okay, so we can start um, this tutorial for R for beginners. I have 4 lectures prepared for this. Today we will cover basic about R and a couple of slides on what the idea of R, how the codes and how people code in R and how they share the code that everybody can use. What a, in the community and our environment and how coders and users connected to each other. Then we will look into a software called RStudio that allow you to manage the coding for different projects. And that will be today's, and on later 3 lectures we will look into data import, basic statistics and graphics. So my name is Dinesh. I'm a senior scientist at University of California, Davis in metabolomics. You can contact me on Twitter and send me a direct message, or you can also use the YouTube chat to, if you have any questions or comments on these videos. So why code in R or any other language, not just R? This is a basic argument of coding and programming. Number one is open source, that whatever code we write or people write in R or many other languages open source, that anybody else can read it and look at it exactly what is happening in the calculation and computation. Then there is a vast active community, which means there are thousands and thousands of people coding in R and sharing the code. So you can rely on other people's great contribution, meaning you don't have to reinvent the wheel, and quite often there is a code already out there that you can simply use in one line. And R specifically provide a range of algorithms for data mining, from basic statistics to advanced machine learning, artificial intelligence, and so on. And it's evolving every year. There are new packages and new algorithms are added into R. Most of the standardized statistical tests that we want to use are already inbuilt in R. So first time you install it, it's already available to you, and in a few couple of line of code you can use them. And R provides beautiful and flexible graphics, so you can create from a simple bar chart to a complex multi-dimensional multifaceted graph for publications. And there are over 10,000 contributed packages. So a package is a code written by somebody, and he shares with entire world through internet. And when we work in bioinformatics and scientific field, a useful paper could be a publication. You can publish the package as it is, as a publication. And on the right side, that's how the code looked. There's a lot of technical words and symbols and loops and all that. So I want to make a comparison here that in classical ways, coding in R was really like a one screen, and there was like this one window where you have to code, and it was really hard back then, like I would say 10 or 15 years ago. But nowadays we have, it's called RStudio software that makes it really easy to code in R, then look at the environment and look at history of what you have coded in like a couple of minutes ago. In the same time, you can see plots, you can see the script being developed, you can also instantly check the console. So RStudio have make coding, R coding, it's like a piece of cake these days. All you have to remember is like what function is out there, what code we need to use or type, and all the logistic about organizing code and everything has been made easy by RStudio software. So the core concept, I'll just cover in 2-3 slides. The core concept of any programming language R is that there are data and there are functions. Data could be anything, and next slide I'll talk about data. But you have input data, and that gets you an output data through a set of instructions. And these instructions are basically the code. In our language, we call them function. So a function is a set of instructions that takes input data and then it generates an output data. So these are two key objects, that you have data and then you have functions. The function takes an input data and generates the output data. What are the data in the R world? Data can be anything that you can see and store in a computer, from numbers, characters, word, phrases, a paragraph, tables. You can have list, imaging, voice, videos. So these are common formats that we see in our computer. All of them can be used as input data or also can be generated as an output data by R code, or not just R code, any programming language actually. So here you need to think about that, what would be input and what would be output around these data, different data types. And then you need to think about that, what we can code to achieve for a given output, what should be the given input, what should be the output. So this is an anatomy of a R function. So now you can get an idea that yes, there are input data and output data. So all it boils down to thinking about what to write with the R function. So let's recap. Function in R is a set of instruction or code that generates an output for a given input. And here, so we have an input and goes through the step 1 to 4, and then we get the output. And so this function, you can name it anything. So like here, it's do something. And these are the instructions you will code. And just to give it a perspective, that there are over 300,000 functions coded in R by people, and those are available on internet. So most probably there is a function already available for what you want to do. And this is where you want to ask Google, because you don't want to reinvent the wheel. So if you just say like, okay, how do I import something into R? And then you will get function, which function means an already coded and tested code in R that you can just call in a single line. So how do I import a CSV file in R? And then you can get this answer that, okay, just use this one line and it will import a CSV file into R, and then you can do something with the CSV file. So most of the time, whatever question or whatever task you want to do in R, there's already a function available on internet that you can get the information that what function will do that job, and then you can just type in your RStudio window. So that's where how our community works. So on the left side we have coders who write these functions, and then they provide you test data. Then they also provide you documentation, then how function works, and they want the test data and how to use it. Then they bundle them together into package. Here is a package X, and that gets submitted to either on GitHub or these websites. And then on the right side, as an end user, you need to call the package, and then you can access all the functions that are inside the package. So this is how our community work, our environment works. that you have a coders on the left side and users on the right side, and users need to call the package, and then they can use the functions inside that package. So you download the package, you install it, and then all the functions inside the package are available for you to use. So that becomes the key concept, that coding in R boils down to one thing: remembering functions and their input and output. And by remembering, I means that you gotta practice. So you need to master as many as R functions by using them often. And then at some point you will realize that I want to do something, but there is no function available on internet. This is where you will write your own function. So you need to master, there are core functions, the basic functions that you will use every day. Then there are functions that are really specific for your own field of research. So if I'm working in metabolomics, so many times every day I see a task that there is no function, then I write my own code and function for doing that particular task. But there are basic things like student t-test or like calculating a mean on average. I don't need to write a function for that because that's already inbuilt in R or available on internet. So you need to know what are these core or basic functions and what new you need to code using them. So last two slides, that important concept one is variable. So a variable is a name. It's like a shortcut, or it's like a nickname to pointing toward a data stored in a computer memory. And so now we're getting slightly technical here. What I mean is that let's say you import it, you're working with the table. So you don't want to import the table every time you have to use it in your code. That's why you call this table by a name. So for example, here my number is 1234, then my number is a variable that represents 1234 data. So 1234 is the data, and my number is a shortcut or nickname, or we call it variable name, that I can use to call 1234 data or represent the data. And you can change it. So later when you're writing the code, you can change my number to any other value, and the value in the memory will be changed. So this is a better example will be, for example, presidents of the United States. So that's a variable name time. So any data can be assigned to a variable as long as you can store them in a memory. An important concept 2 in R is called vector. And a vector is a collection, one-dimensional collection of data. Like if you think about Excel, so it's either one column or one row. That is one vector. So here, a vector user is a collection of these six names. Or vector my number is a collection of these seven numbers. And you can also have vector or variables itself. Then you can have my health as a variable that it includes my blood pressure, height, BMI, weight, plus and blood glucose. So a vector is a one-dimensional collection of data or variable or information. Now this is the core of R. R is a vector language. It creates vectors by any input data. So I will go back to the previous slide. That remember, variables are names that points towards data stored in a memory, and data changes, but variable name can point towards the same data or the updated data. And vectors are one-dimensional collection of data or information. You can have names, you can have numbers, you can have other variables as vectors. So these are two key concepts in R, variables and vectors. All right, so now we can dive into the coding part. So I hope you guys follow the Google Doc to you have followed the Google Doc to install RStudio software and R. I'll just skim through the Google Doc that what it explains. So basically you need to set up the computer and you need to download the latest R and RStudio software. I recommend using two monitors or a lot bigger screen so you can see the tutorial and you can also follow it on the second screen. So if you have two monitor, it will be a better experience for you there, because otherwise you need to switch between two software. So, and you download a latest R and downloaded RStudio software, you install it. And now let's go to, and then RStudio software looks like that. I'll explain live on the RStudio what are these different windows, but I'm assuming that you have run this part of the code, from here to here, in the location star on the RStudio, and press enter. So this code basically install a couple of packages from internet. It download those packages listed here like DevTools, Read Excel, Stringy Loading, and so on. And then it tested that if one of these packages is installed and it's working. So if it throws an error, that means you need to do something with your computer or installation of R and if there is an error. But I'm assuming that there is no error if you install the latest R and if you install the latest RStudio software. And you should see this plot on the right side of window on RStudio. So let me just do a demo of this part and how it should look. So I just copy it and paste it. So that's how it will look. It will install the software. Depending on your internet speed, it might take some time. So while it's downloading, I can explain you the RStudio windows. So in RStudio, we have 4 panels. So you can see these 4 panels here. Let me adjust them a little bit. Okay. Yeah. So this is the panel where you will type the code. And on the right side panel, it shows history or what objects have been stored in the R memory. And right side below, that is the the window where files are available for you to use. You have plots, this is where you will see the graphics, packages, these are all the packages that are available to you. Then you can get the help, or you can get the help about different functional packages, and you can search the topics that if you want to have help about a particular function, then you can type the name here and it will find if there is a documentation about that particular package. On environment side window, we have history. This is where you will see all the codes that we have run, and I will say ignore these three: last, connection, build, and get. These are more advanced programming things. So all you have to care about environment and history. These are two tabs you will interact more. So now let me run this command. Okay, I'll run just this command. So yeah, my screen is small, that's why, but you will see this plot, and that means R is working as we want to use it. Okay, so you want to see this plot, and depending on the screen size, you will see over these crowded labels or overlapping labels. So now we will follow on the script on my screen. I have written some of the basic things that we will cover in terms of coding. So the very basic operation in R are arithmetics, logicals, and number sequence. And before that, I need to mention the project organization. So in the Google Doc, I explain that for each idea or task you're doing, you want to create a new project, which means you click on this right side arrow button and you click on new project, ignore that one, and then you click on new directory and R package, and you type a package name here. So this one R101 is here, but whatever work you do, whether it's a study or a project, or whether it's something about like a bigger package development, you type that. It has to be intuitive. It has to be something that people can understand, like what this package is about, what this coding or this collection of code is about. So here I just use R101 2020, you're using R101. And in basic RStudio, you always have these typical Windows options, like you click on file, then you can generate new files and all these other options. They're pretty intuitive, like the name reflects what you can do with, like open a file or save or rename, all that. And the other options, you don't have to pay attention, learn them right now, because you pick them later. So right now all you have to worry about is that the most important thing is that for every project you create, every idea or question, you create new project, and then you work in that project. And next time when you want to come back to that project, you can go to open project, or it will be listed here in the list. So that's how you can manage and organize the coding part. So here we are working under R101 2020. For you it will be R101 project, and all the codes for that project are in R directory. So in the files you see R directory, and all the codes will be stored here. And if you want to copy, you need to copy files in this directory. I have a detailed instruction in the Google Doc. So if you get stuck anywhere, you can always go to Google Doc, and it's very well explained there. So if you need to copy data files into this place directory, and for that you need to click on More and Show Folder in New Window, and it will open this project directory into Windows Explorer, and you can see the location, where exactly the location is, and whatever you copy here in this directory location will be accessible directly into the RStudio window. So for example, I copied two files, R101 delimited data and R101 test data at this location, and then I can see them directly here, R101, and they are available for me to import in my scripts. So this is handy because you get an Excel sheet, you get a CSV file, you want to copy directly them into this location, so then you can call them into R codes. So those are two things of organizing your codes and files. Let me quickly recap that you always want to click on new project, create a new project for whatever ideas or question you're working on, and then you want to copy your test data or your experiment data or study data or whatever the input you want to use in that location in files, and for that you click on More and Show Folder in New Window and just copy in that window, and you will get those data directly here. So now those are the basic idea about organizing your code, and it's really important because you don't want to have all your script and code into the disorganized way that they are lumped together in one directory, and then you will be lost completely that which script belongs to which project, which data belongs to which project. The RStudio makes it really easy this way, so that way, and then the code evolves, so that way you can see that what projects we did last year, what were their data, what script I did, what new development I need to do for them. Alright, so let's come back to the very basic operation in R or any programming language are arithmetics, logicals, and you can create some sequences. So R works as a computer or calculator. These are basic numerical operations. So on your R window console, you can type 1 plus 2 and it will give you 3. Yeah, so R understands these basic mathematical expressions. So 1 minus 3, it will give you minus 2, or 45 divided by 6, it gives you 7.5. So and what we need to remember are these symbols, that plus, what the plus symbol is, what's the negative symbol is, what's the ratio symbol is, and what the multiplier. And so these symbols are really typical in they're coming from our basic education. So we know what a plus sign is, we know what a negative sign is, we know the ratio sign and multiplier sign. So these are the symbols that you will remember. You will use them almost every day, or every script will have these symbols. So these are basic 5 symbols. So you have a plus sign, you have a negative sign, you have ratio, multiplier, and a power. So if you, now then there are logicals, which are true and false. So basically, if 1 is greater than 2, it gives you false, or if 2 is less than equal to 1 or 2, it's true, and if 2 is not equal to 1, it's true. So these are the way logical operations are. So you have a greater than, less than, equal to. So in R, equal to symbol is 2 equal to sign, and that's a little tricky. So if you want to check 1 equal to 2, but if you say 1 equal to 2, it will throw an error, because in R, equal to sign, single equal to sign has a different meaning. We will cover that in the later part. So if you want to test if 2 values are same, you will use 2 equal to sign. And this symbol represent exclamation marks, equal to sign represent not equal to. You can also combine 2 conditions. So this vertical line represent or, so it's 2 not equal to 1 or 2 is greater than 1. So you can combine multiple logical testing. So it's actually it's 2, yeah. So you can have several of them combined together. This one, so 2 equal to 3. So here, since it's a vertical line, if any of these 3 tests or conditions are true, it will throw a true out. Okay, so that was basic arithmetics and basic logicals. Then we have sequence. So often you need to create a sequence from 1 to 5. Then you need to use the colon symbol in R. So a colon symbol creates a sequence from a starting number to the number on the right side of the colon. So you can have 1 to 10 or 110 to 200, and so it will create the sequence. Now these sequences are useful when you do coding, because sometimes you need to get the row numbers from 1 to n, or you need to create IDs, or you need to create unique row names. Then you can use these sequences quite often. 2 shortcuts you need to remember: Control plus L. So if you click Control plus L, it will clear off this window here. It didn't delete everything, it just clear off, it give you a white screen so you can type more. And if you click on up and down arrow, then you can see the previous code that you have run. So that is with up arrow and down arrow. So up and down arrow will give you the previous code. And if you click on Control plus L, it will basically clear off the console screen, and then you can get an empty screen to type the code. So let me recap. These 3 are really important, or I would say core of R coding. Arithmetics, you need to remember these symbols. So you need to get a good grip of what these symbols are, what they mean. So some are intuitive, like plus is intuitive, negative is intuitive, ratio is okay, this multiplier sign is okay. The power symbol, like this tant sign. And then you also need to remember these logicals, that what are these logical symbols are, and this colon symbol for sequence. These are easy symbols. But you need to remember them, and by remembering means you need to try them out quite often. That okay, I wanna look at plus, minus, multiply. Just try them out with different numbers. But you will be needing them every day, or every time you code. You will need these symbols. So now the next thing is called variables. And in the PowerPoint slide, I explained what the variables are. So these are pointers or nicknames or shortcuts pointing towards the data stored in the computer memory, or R memory. So what I meant by that, before I jump into variable, I want to explain. So we just saw now how do we typing numbers, like you can type 1 plus 2 or 1 plus 2, and understand that it's a number, and it sees that there's a plus sign between them, so I need to do a addition, and I'll I'll output 3 there. Now you wonder, like, oh, then how does R works with characters or alphabets or words and sentences and paragraphs? And this is where this symbol quotation mark comes in. So anything between two quotation mark, whether it's in a small quotation or whether it's a single quotation or the double quotation, it's R thinks that is a character. So if you type 1, it becomes a character. So two quotation mark, anything in between that, R will interpret that as a character, and it will not do any of the arithmetic operations on it. So now if you think like, okay, what I mean is that, so if you put two quotations like that, R will think that no, I cannot do it because it's not number. And it says no numerical argument to a binary operator. Even if one of them is number and one is a character, it will throw an error because it doesn't know what to do with character plus sign. So this is where the idea of alphabet and characters come in, that anything between double quotes is a character string. A string is many alphabets. So a word is a string, 2 words is a string, or many words is a string, and an alphabet, a character, is a single character. So this is considered a single character, and that's like the whole string. It's called string in our language. So if I type just control, it will select one other thing I need to mention here on line 44, that if you select this part of the code or one line and then you click on run, then it will basically run in the console. So you can select any number of lines and then click run, it will run it. This symbol hash sign tells R that ignore anything after that. By ignoring means it will not do any computation. It will just ignore it as a comment. So hash sign is helpful when you're writing documentation, when you're writing comments. For example, I just use here as a pointer that I need to explain assigning variables. and then I need to do a exercise 1. So this is anything after a hash sign, a hash symbol it's not a code. You can R will ignore it. So now that was line 44. Again, explain that anything between double quotes is a string, it's a character, that I will not do numerical operation on it, which means that it will not do addition, multiplication, or subtraction on a character string. Now, idea of variables. So we can say that control is the data here in this case. So control string is the data, and we call it an X. So we basically calling this value control as an X, and the symbol we using, it's this symbol less than and a dash. So it's basically somewhere on your keyboard, close to like a pod sign. Yeah, different keyboards have different layout, but you need to find this symbol. So these are two keystrokes. One is a lower k less than symbol, and then other is a dash sign. And so X is assigned a value control. So now, moment you press enter, you see a value X in your environment here. So you see, okay. Yeah. So on the right top environment, you will see a value X. What it means that you have stored value X in the memory, and then you can call it back just by typing X. So now this shortcut X represent the data which we stored as a control in double quote. So you can see on the environment side here that X represent this value control, which is just one word now for simplicity, but this could be a whole line, a whole paragraph, a table of 10 rows and columns, or a table of million rows and column. All you have to do is, like, now X represent this value stored in the memory. Now this is the assignment symbol. We call it the assignment symbol, and it's also, you can do equal to sign. It's the same thing. So equal to sign, a single equal to sign in R is an assignment symbol, that you are assigning a value in the memory to a variable name or a nickname or a shortcut. So that's why when you're doing the actual equal to operation, you need to use two equal to symbols. But when you use a single equal to symbol, it means you're assigning a value to a variable name. So which in this case we have value control, which is a string assigned to variable X. Now I want you to do an exercise. I don't know, maybe you can read my screen from line 8 to 26. If you can read, type in your YouTube chat box how many variables you see. Not the value of the variable. Type in YouTube chat box how many variable names do you see. I'll wait for a couple of minutes. So you go through line 8 to 26. This is just an R code, and all you have to do is read from there and find out that how many variables or which word represent a variable name, and you can just type it in the YouTube chat box. So for example, I can see the directory has an assignment operator right to it. That means directory is a variable name. Or I can see RT delta has also an assignment operator next to it. So RT delta is in a variable name. And then you go through the entire code like, oh, there is a variable name dir1, and there's the other variable name mgrt list, then the other variable name file list, and then I'm using file list again, so I'm changing file list variable again, and then I have x file, peak table, spectra list. So these are different variable names because they have assignment operator on their right. You can interpret this as in this way, that anything, any word at the left side of this symbol, assignment operator, is a variable name. So you can look at this code and try to find different variable names, and you can type in the YouTube chat box, or you can write it down on your page or make a note that I understand in this code how many variables are there and what are their names. So this is basically we're skimming through a code and trying to find that what are different variables names we have in a particular piece of code. And the trick is, again, that anything left side of an assignment symbol or a single equal to sign is a variable name. Okay, so that was okay, you need to type the names too, not the total number. So that was about variable and how do you spot variable in a piece of our code. So anything left side of assignment symbol is a variable name. Now the next part is functions, and a variable represents a data. So you can see that, oh, it represents a data, so I could use a variable as an input, or I could generate a variable as an input. Absolutely right. So you can use a variable name which represents a data stored in memory as an input for a function code, or also a function can generate a data that can assign to a variable name. So now we need to cover the function, like, okay, that's great, like we understand the variable, we understand that a name can represent a data stored in the memory, and that data could be anything, and variable names are handy, so I don't need to type the whole data in the code. I can just use a simple word, an intuitive word, that what the data mean, what the data could be. So now the function part. So function, as we explained in the slide, have input and output. So a function takes an input always, and it will do something. Now in R, functions are basically words, and they for example, square root of 6. Yeah, this is a basic example of a function in R that takes the input 6 and compute square root for that. So in R code, I'll jump direct into this code. anything, any words on the left side of a parenthesis sign, it's a function. So when you read our code, any word on the left side of a parenthesis side is a function. So in this case, we have, for example, from the top, so I read line 13, there is a function get WD. Then line 14, there is a function set WD. Then line 16, there is a function read.dlim. Then line 18, again there is a function dir. Then I have function again line 20, because there is a parenthesis here, I have function length. So this is other way to spot functions, that anything on the left side of a parenthesis is a function, a word that represents a function. And again, the function is basically a set of instructions or code, and we can use that code just by calling this function. And by calling, I mean that you need to type that function name and then start with parentheses, and then you need to provide an input. Now the question here, like, okay, how do I know what type of input a function takes? And this is where you can use the help in R. So you type a question mark sign in front of a function name, and it will explain you that what kind of input the function expects and what will be the outcome. So here I type question mark square root, and it gives me the documentation that, oh yeah, the square root x, and x has to be a numeric, and then it will give me the output, which will be a numeric too. Yeah, so square root returns an integer. So that's the basic idea of function, that in any R code, a word before the parentheses is a function. It's a name of a function, and function takes input and it will gives an output. And you can find what is the input and output in documentation for that function. So here I use function square root. So I open the parentheses and I close it, and I put 6 in between those two, and then I got a value back. So that here the input was just one parameter. But then you can have function with two parameters, like I want to calculate log of 5, but instead of log 2 I want to have a log base 10. And so this is a function that takes two parameters. So a log function input is 5, and then you can change that what base it should use to compute the log. So you have two parameters, and then you can think about, like, oh, I can have any number of parameters. Yes, that's true, but then it's hard to manage if you put like 100 parameters. So I would say, don't go more than 4 or 5 when you write your own code. And there are complex functions which really have 20, 30 parameters, and those are really technical, and you won't see them at the early stage. At early stage, your functions, the functions you will be dealing with, will have only 1 parameters in the input, or maybe up to 5 parameters, not more than that. So I explain the function, I give the idea about input and output, using example of square root, and how to spot functions in a code, that anything before in parentheses a word represent a function name. And functions can have input parameters, like you can have input data, one type of data, or you can have multiple parameters. How to get help on the functions? You type question mark and name of the function. If there is a documentation, you will get it, or you can always Google it. So I think this 1 hour is over. I will not cover the last part. I think it's best for the next lecture, that what are the vectors and what are the data frames. So I'll cover them in tomorrow's lecture. But today we looked at basic of R, the packages, the functions, variable, idea variable, and how do you type in the console, and how do you type in the script window. So and we cover the basic operations, and tomorrow we will cover the data object type, and we will get a little more technical tomorrow. I wanted to keep it simple today, so not too much typing for you, just the basic mathematics and assignment of 1 or 2 variables, and reading a code that can you spot function name, or can you spot variable name in a code. So thank you guys for listening, and I'll see you tomorrow. Bye.